everyone, today we are going to build our to-do list app using Tailwind CLI and raw JavaScript. So in this to-do list, what we can do is we can add a task, then we can also check after our task is finished, we can also delete the task, etc, etc. So in this video, what we are going to learn is how to install the Tailwind CLI. Then we are going to see how to add the task in this page using JavaScript. I mean, how can we keep this dynamic? How we can control this from the front end? Then we can add the functionality like checkboxes and delete buttons. You can see this where we add the checkboxes. Then we can also delete this. Then we are going to learn how to save the data and load when the page is refreshed, so that we do not lose the task list after the page is refreshed. So if I refresh this, you can see we do not lose the data. Then we are going to enable draggability. For example, you can see I can drag this, right? Then we can also sort this. So actually this will be enable draggability and make it sortable. Then we are going to see how to push our code to GitHub. So these are the things that we're going to learn in this video. I learned Tailwind CSS from Code with Harry. If you don't know him already, he's a famous Indian YouTuber who makes videos on coding. So this is a screenshot from his video where he is explaining how to install the Tailwind CLI for a project. I find this site very helpful as it not only tells us the commands and steps we need to follow, but also explains their function in the terminal. You can see we have two classes here. One is the background class and another is to-do list class. So we want to add a margin top of 100 pixel to the to-do class div. However, as there is no text or images in the background div, the margin gets applied to both of these classes, to both of these devices. This could have been eliminated if there was a text like this. You can see now when I add a text here, the margin gets applied to only the to-do classes and there is that gap between them. instead of writing a text here, I add a transparent image and make its width 1 pixel so that it doesn't take up much space. However, if I add a border to this, you can see there is actually a transparent image there. At first, we select the different elements, that is the add button, the input bar, and the task list. Then we create a function named add task where we will write our logic. Then we need to create two event listeners. First one is where the add button, when the add button is clicked, it will call the add task function, or when the enter key is pressed in the input bar, it will call the add task function. We can see both the events are working correctly. Now let's go back and add our logics to the add task function. Inside the add task function, we check if the string is empty or not. If it is not empty, then it enters the if block. Inside the if block, we create a list item. Then we create an image. We also add the image.src. Then we create a span where we write our text content or the task content. Then we create a button and name it delete button. It is the button that will delete the whole task. And then we add the necessary classes to style it. So far, I have shown you how to install the Tailwind CLI, and now I have shown you how to add the task using JavaScript. Then we create another function named add functionality. At first, we add an event listener to our image tag so that when it is clicked, the images that was set changes. So for that, we need to find what our image src will be when we click that. So we can find that using console.log. We console.log our image.src. From there, we can copy this and paste it in our condition. Then we need to add a strike through line to our span. Then we also add an event listener to our delete button where the task will be deleted when the delete button is clicked. Now we want to save our list so that when our page is refreshed, the task list that we have written doesn't go away. For that, we name a function called save task and use local storage.setItem. It takes in two parameters. First is the variable under which the items will be stored, then the second parameter where the items that you want to store. So we write tasklist.inner HTML and the variable under which it will be stored is data. So this data function is actually stored in our local storage. Then you naming another. Then to retrieve this data, we name another function called load task where we can fetch this data using local storage.getItem and the variable after which we have named during saving. Now if we call the function load task, it will automatically assign task list.innerHTML to the stored data. Here I am trying to debug this problem where you can see if I click on the delete button, it automatically removes all the tasks from the list. Let's check this out as well. We can now save the data and load the data when the page is refreshed. Now we will add another class name Draggable so that we can identify and select this list class by this class name. We get all the draggables here. Then we will run a for each loop to iterate over all the draggable list items and add an event listener. So we are adding a dragstart event listener whenever that particular list item is being dragged. We didn't call this function. Okay, see, when I started to drag this over, you can see a dragstart just like that. Dragstart, dragend. So we can use this to add a class to our drag list items, dragging. So what this suggests is when a list element is being dragged, it adds a class named dragging, and when it is dropped on the drag ends, we will remove this class. Now we need an event listener named dragover. To help you better understand, let me console.log on every drag event, so that when these events get triggered, we can check on our console. At first, when any list item is being dragged, the dragstart event gets triggered. After that, when that list item is being dragged over the other draggable list items, we can see the dragover event is being triggered. As soon as I move my cursor out of the draggable zone, the dragover event does not get triggered. And when we drop the list item, we can see that the dragend event is being triggered. Inside this dragover event, we need to find the list item that is closest to the list item that is being dragged. To get this element, I create a function named getDragAfterElement. At first, we select all the draggable list items except the list item that is being dragged. Then using spread operation, we convert this into an array so that we can use the reduce function. The reduce function is a callback function that iterates over the whole array and returns a single value according to our logic. The reduce function can also be compared with a for loop. I am showing you two screenshots of the same logic, one with the reduce function and another with the for loop. The reduce function takes in two arguments, the first one usually being a function inside which we write our logic. This function will have two parameters. One is the variable that will be returned and another is the variable that iterates through the element in the array. The second argument of the reduce function is the initial value of our accumulator or the value that is to be returned. The logic inside the reduce function we are going to use is however somewhat complex. So let's go through it. Here we are iterating through the list items that are draggable, excluding the list item that is being dragged. Our goal is to find the list item that is closest to the dragged element. So naming the variable that will be returned as closest, and the iterator is named li. Setting the initial value of the closest as an object containing vertical distance, where vertical distance is equal to -infinity. The vertical distance is the distance between the midpoint of other list items and the y-coordinate of the cursor on the screen. To find the vertical distance, we use the function getBoundingClientRect. This provides all the position information of the iterator or the list item. A point to be noted here is that the value of y increases as it moves downwards of the screen. From that, we can find the midpoint by using this formula: position.top plus position.height divided by 2. Here I have drawn a graph to give you a visual understanding of what I am trying to say. Imagine this rectangle is our list item. Its top is 180, bottom is 340 units. Height is 140 units. To find the midpoint, we use this formula. Then we find the vertical distance. This is the calculation we follow to find the vertical distance. The vertical distance from y to all list item is then calculated. Imagine I drag the very last list item and brought it between the second and third list item. Now if we calculate the vertical distance from each list item to our dragged list item, we'd find this. We want to return the highest negative number here. So we would return list item number 4. If we go back to our code, I will show you how I implemented this. We only want to find the closest list item that is below the dragged item, so that we can use the insert before function. So the midpoint of the closest item that is below the dragged item will be greater than the y coordinate, making the vertical distance negative. Also, as the initial value of the vertical distance is -infinity, the vertical distance from a list item will certainly be greater than this. If both these conditions are fulfilled, it enters the if block and updates the closest variable. Here, an element key also gets updated, which tracks the closest element, and the vertical distance stores the vertical distance from the list item to the y cursor. After the full draggable list is iterated, the close variable now stores the highest negative vertical distance and its corresponding element. We need to return only the element here, so we use .element at the end of our function. We can now use this information to insert our dragged list item on top of the element we received from the function. Now let's upload our code to GitHub. To do so, at first we need to create a repository in our GitHub. Then write git init in our terminal to initialize inside our folder. Then write git add dot to stage all the code we have written so far. Then commit this and write a message along with it. Then connect our local git to our GitHub repository using the git remote origin. Then push the code using git push origin. Now let's upload our project in GitHub pages, where we can view our project outside our local host. We also need to make another change. We need to add the Tailwind place CDN so that the Tailwind classes styles our element as we want to. Sometimes it takes time to view the changes we made to our code in our GitHub pages. So let's come back after a few minutes. We can see it is now loaded perfectly and everything is working perfectly from the GitHub pages. Thank you everyone. See you in another video. Bye.